Hi, in this video I'll be demonstrating how to fault trace and repair either your earphones or your headphones. Right, so I have these white earphones here that are not working. When I plug them in, there's no sound. So how do I solve this problem? Right, the first thing is to inspect the unit. Right, I start over here and I inspect the unit. There's no tears over here, there's no broken plastic. Right, having a look at this one, you can see that right there where the wire comes into the plastic, it is starting to tear. So this is a fault waiting to happen. It might even be broken at the moment, but this is what I'm looking for. I'm looking for tears in the plastic, anything that stands out. For example, on these headphones, notice here is the wire and it's popped through the protective covering, even on the other side, and it's because of this movement. So this is what I'm looking for. I'm looking for things like that. In this case, both sides are actually working. But in the case of these white in-ear earphones, they are both not working. So what I'm doing is I'm feeling the plastic here or the rubber. I'm feeling to see if it is uniform. What I mean by that is because there's a wire running in the middle here and there's also a nylon thread. For example, if you look closely here, you might be able to see that it's not only a wire, there's some thread that is running there. That's a nylon thread to support this. So if it's pulled like that, it won't snap the wire. So I'm feeling to see if that has a uniform flexibility. So what I do is I take my finger and I gently pull the wire, and I'm feeling the wire for any imperfections. Does it get fatter or thinner? That also means something. And also, does it suddenly become elastic? At the moment, there isn't much elasticity. There is almost no free play here. Right, over here I have this yellow wire. I'm going to use this to explain what I'm doing. See, because the wire is running inside the insulation, the wire is copper and in some cases aluminium. It has no elasticity. For example, here's a piece of copper wire. If I pull on it, it doesn't stretch. So what I'm doing is I'm feeling along the wire to see if the protective covering, this yellow covering, stretches. Now, what I mean by that is as follows. If I remove the wire from here, I'll show you what happens. So what I'm doing is I'm pulling the wire out from the insulator. Right, so now there is no wire inside this yellow insulator. Now watch, when I pull on the insulator, it's stretching. Look at that. It's at least 3 or 4 millimeters. I can feel it stretchy. It's now stretched half a centimeter. And that's what I'm feeling for. I'm feeling for any stretch in the wire. So if I go back to the earphones, I'm pulling it and I'm feeling whether there is any imperfections. Is there any bump? Is it flatter at some point? And does the insulator stretch? Now this whole section is fine. So I know that there's no break over there, and I've already tested the other side. Now I'm going along the lead towards the jack. This is the jack or the plug. So I'm pulling along here and everything is fine. No imperfections at all. Yeah. And over here, I just noticed something. First thing is, in my finger, it felt thinner. And look at this. Now, this should not happen because the wire inside is not elastic. So the fact that the protective covering, the insulator, is moving like this means the wire is torn. This means that this probably got caught on something and somebody pulled it and it broke the wire inside. I'm almost certain that if I cut here, I won't see the wire. The wire would have moved because this has stretched. So I can also feel that it is thinner here. And I can feel just there's the beginning of the wire because suddenly it gets fatter. So I'm going to have to cut this and I will show you what I'm talking about. There's no wire inside there. There's the 2 wires torn, and over there you can see that they've gone inside. So what I need to do now is rejoin these wires. Right, I just need to expose the wires. Ideally, it's best to use wire strippers because wire strippers have a hole there, and that means I won't cut through the wire here. If you haven't got wire strippers, you can use side cutters. Just remember to make an impression like that, but I don't cut through and then I just pull off the protective covering. You can also use your nail, so sometimes the protective covering is quite weak and it just comes off. Okay, so there we have the exposed wires. Because this is in the middle of the cable, I don't want to have insulation tape around the repair. So what I'm going to do is I'm going to use something called heat shrink. What this is it's a tube that when I heat it up with an open flame, it shrinks, and this will offer some rigidity and protection once I've repaired those wires. So I'm going to take my heat shrink and I'm going to put it on the wire. So I'm going to put it around the wire, so it doesn't have to be this long, but I'm just going to use this length for explanation purposes. And there I put my heat shrink. I'll just have to open a bit more here. Right, so there's the heat shrink there and here. And then you could even take another heat shrink. I'll just put it here as an example, and then this will be pretty much as strong as it was. So in this case, we've got probably a left and ground and a right and ground. So they have the ground wire over here and over here, because there's 4 wires and usually there's only 3. So I need to make sure I've got my 4 wires here. So I'll have the one and then the other, and then the one and then the other. Now over here I have my multimeter and I've set it to continuity. If I touch the 2 leads together, I hear a beep. That beep is telling me it's a short circuit. Also notice the meter says zeros, telling me it's a short circuit. Over here I've got an exposed copper wire, and I just want to show you that when I put my one lead over there and my other lead anywhere along this wire, even if it's just 1 or 2 strands, look at the meter, short circuit. Now what happens with these earphones and headphone wires is they have an enamel on them. Sometimes it's an epoxy. So if I take my earphone lead and I do the same thing, notice there's no conductivity. If I go on the red one, there and there, I'm going between there and there, nothing. And here on the red one, nothing. And the reason being is because there is an enamel layer on top of that wire. So what I need to do is get that enamel off. Now, an easy way to do that is to just take an open flame and burn it off. Right, I'm going to start with this side, and I'm just going to take an open flame, and you'll see that it actually burns off. You might even see an extra flame as it burns. Look at that. Did you see that when the flame went like that? Right. So again, there. So it's burning it off. Now, sometimes you have to do more than this. You even have to sand it to get rid of that enamel. But in this case, I can see that it's already looking good. Now, on this side here, I'm going to do the same thing. And over there. Now on the other side. And now what I need to do is I need to twist them together. I must just remember the orientation. So the red goes with the red. And then the copper color went with itself. Right, I'm just going to do one side at a time. Now I'm going to take my soldering iron and just put a little bit of solder, and you can see that it will solder now that that enamel is off. And just a touch of solder there. So I'm just tinning it really. Now I can cut it a little bit shorter. Right, so that side is now done, and I could even test it with the radio. Right, so I have some music playing and I'm just testing the one speaker. So one speaker should be working. Right, so the one side is working. So right now what I'm going to do is I'm going to push these down. So the one is on the one side and the one is on the other side. And now I'm going to put the heat shrink over it. Now I'm going to heat it up. Right, so the one side is now repaired. Now I'm going to do the exact same thing on the other side. Right, so I'm just separating them, one on one side, one on the other side, and then I'll put the heat shrink over, and now I just heat it up. Right, so there is the repair, and I'll quickly test it. So the left and right are now working, and now I just have this last heat shrink just to go over it for additional strength. Right, so there is the repair, and they're bending. Doesn't matter what I do, it's still working. I can still hear the sound. Another common place where there's damage is on the strain relief of the plug. So for example, you might find that right over here the wire is broken, or inside the strain relief, or it's already torn. What you can do is just get a new one of these DC jacks. Now some headphones use the full 6.3mm jack. So if I were to repair that, I would buy a replacement jack. I need to solder the wires, the left, the right, and then the earth or the ground, which is here. on the 3.5 millimeter, it's a bit smaller, I would just cut this. I'll just solder it into a brand new 3.5 millimeter jack. This particular jack is a mono jack. That is why there's only one signal wire over here. There's signal and ground. For a stereo, it will be two connectors on the inside plus the ground. Lastly, sometimes you can use a multimeter to do some tests. If you've got access to the speaker, for example, over here, I can open this and get access to the speaker. Right, there is the speaker. And I can also do a measurement to see if the speaker is blown. So I'll put this onto resistance and I'll measure resistance. There's 0 ohms. So if I measure across the speaker, in this case, it's 30 ohms. So then I know that the speaker is not blown. I can also do a test to measure the resistance from there to the jack. If the resistance is very low, then I know there's no damage to the entire cable. So for example, if I put my lead over here, on the first point over there. And if I want to check the resistance, 0.7 ohms, 0.6 ohms, that is a dead short in terms of resistance. And that means that this wire goes all the way to this point without any damage. Now, if I measure on the other lead, there I'm getting 32 ohms. That is the resistance through the speaker. So if I hop to the other terminal over there, I'm getting a short. So it's telling me that that is working. If I measure the others, I'm getting 33 ohms, and over there I'm getting 30 ohms. So these are good values. Now I just want to get the lowest one. So I'm moving my lead to the other side of the speaker, and I'm moving this lead over here, and there we go. I get 60 ohms. That's also okay, but there we go. That's the dead short. So what that tells me is that that speaker is connected to there and there, with less than 1 ohm, less than 1 ohm. So that means that this speaker is connected to the jack with no problem. Now I can take this one step further, and if I use these crocodile clips, what I can do is I can put my crocodile clip here on the edge, and I know that that is connected directly to that point over there. If I use my other crocodile lead and I clamp it to that point over there, I'm getting that very low resistance. So I'm measuring between the one side of the speaker and the tip of the jack, because that I've already determined is the short circuit point. So that means that that is the wire going from there all the way to the tip. Now, if you had a problem like you were listening to your music and then you moved the earphone and then the sound went off, or you bumped the wire and the sound went off, that would mean somewhere along the cord over here there is a break. So what you can do now is you can take your hand and you can do this. What this does is it locates a break in the wire. If there was a break here, by pulling on this and fidgeting with the wire, suddenly that resistance would go way higher. So if I was going like this, and next thing the resistance went to 500 ohms or 10,000 ohms or even an open circuit, then I know, all right, somewhere in this wire there is a break. Now, if you haven't got a multimeter, you can also do this test using the music. For example, you could plug this side into your phone. Right, so this side I'm plugging into the music is playing, and I'm listening to the music, and then while I'm listening to the music, I play with the chord like this, section by section, and I make sure that remaining chord is not bumped. So this would be in my ears, and at one point I'll probably hear the sound stop playing. Then I know, all right, over here we have a tear in the wire. This is where the break is. I can fix it over here. All right, so I hope that was helpful, and thanks for watching, and cheers.